Whenever you are dividing any number by single digit, any number, any given number, x can be any given number, by single digit, how will you divide? Now let us see. Whenever you are dividing any number by single digit, say from 2 to 9, one thing you can do, you can follow the normal conventional method only, but in a different manner. How? See here. For example, 47368. I want to divide it by 4. 47368 divided by 4. Anyhow, we'll start from the left side. So 4, how many times goes in 4? 1 time. Next, remainder is 0. Now 7, how many times goes in 4? 1 time. 4 ones are 4. What is the remainder? 7 minus 4 is 3. Put that remainder before the next number like this, just above the top. Before the next number, just above the top. Now it became how much? 33. How many times it goes in 4? 4 8s are 32. Remainder again, 33 minus 32, 1. Put before the next number. How many times it goes? 4 times. 4 4s are 16. Next, 8. How many times? 4 2s are 8. When there is no remainder, that means when I am getting the remainder as 0, I didn't put any 0 there. Why? Because everybody know, even if you put or we don't put, it doesn't make any difference. Now let us take one more example. 73975 divided by some 7. I want to divide it by 7. First, 7. How many times it goes? 1 time. No remainder. Now 3. How many times it goes in 3? Will it go? It doesn't go. But even I can say it will go, but 0 times. 7 zeros are 0. Now put the remainder, that is 3, before the next number. Now it became 39. How many times it goes? 7 5s are 35, remainder 4. 47 it becomes. 7 6 are 42. 47 minus 42, 5. So remainder 5. 55. 7 7 are 49. Remainder finally 6. Now if you want the answer in decimal points, let us take some 2 digits up to. Put a point, you can add a 0 here. So 7 8s are 56. Again 4. Again you can add a 0. 40. 7 5s are 35. So if I divide 7397 by 7, my answer is 10567.85. Even you can do in the same way if you know up to 20 tables. Let us take some, see, 3, 4, 8, 7, 6 division by some, say, some 14. Okay. Now, 3, will it go in 14? No. So take 34 at a time. How many times goes? 4 2s are 28. 28 and 6 is my remainder. Now it became 68. 68, how many times it goes in 14? 14 4s are 56. So 14 4s are 56. That is, the remainder is 12. Now the next, it became 127. How many times it goes now? It became 14 9s are 126. Remainder 1. 16. 14 1s are 14. Remainder 2. Put a point. It became 0. 14 1s are 14. 6. 0. 14 4s are 56. So your answer is 2491.14. One more example. 37896 divided by, say, some 19. So first 3 doesn't go. So 36, yes. But how many times? Only 1 time. 37 minus 19. How much? 18. So 18 will be my remainder here. 188. How many times it goes? 9 times. 19 9s are 171. So what is the remainder? It's 70. How much? Yeah, it's 70. The remainder will be 17. Okay. 188. 19 9s are 171. 188 minus 171. So the remainder is 17. It became 179. How many times it goes? 19 9s are again 171. Remainder is 8. Now it became 86. So 19 4s are 76. Finally the remainder is 10. Put a point, you can add a 0. 19 5s are 95. 5 0. 19 2s are 38. So what is our answer? 1994.52. Like this, we can divide any number by single digit or double digit. Up to how many tables do you know? That many. Until there you can divide like that in a single line, just putting the reminders every time before the next number, so that you will get one clarity to divide the number easily. Now let us see the next method in our Vedic maths for the divisions. Now let us discuss one more important method in our divisions, that is Arthur Benjamin method of division. You can divide any number by any number in this example, but One thing you want to know, even though I am saying it as Arthur Benjamin method, it is Vedic maths method only. Why? Because Arthur Benjamin is a speed math specialist who developed his method using the Vedic maths methods. Now let us take one example. Suppose 5324 divided by some, I want to divide it by say some 29. First of all, write the 29 here as it is. 5324. Anyhow, in this method, last digit is always for the remainder. Now you tell me 29. If you make it a round figure, okay, its nearest tens is 30. So take 30. Leave the 0. To get 30, what I need to do? I have to go for 1 addition. Yes or no? 29 plus 1 will give 30. So plus 1 will be my complement. And now what I am going to do? I am going to divide by 3. But indirectly I am dividing with 29. Let us see how. So first take the first digit as it is 5. So 5, how many times it goes in 3? 1 time. 3 ones are 3. What is the remainder? 2. Put before the next number. Now 1 should be multiplied with the complement here. Every time the quotient figure should be multiplied with the complement and add it to the next number. 1 into 1. Add it to next number. 1 into 1 will be 1. 23 plus 1 is how much? 24. Now 24, how many times it goes in 3? 8 times. So what is the remainder? 0. Exactly it goes. Now 8 into plus 1. 8. Add it to next number. 2 plus 8, 10. Again 3, how many times it goes? 3 3 is a 9. 1 remainder. 3 into 1. Add it to next number. 14 plus 3, 17. Now this is my final remainder. Okay, this is my remainder. Here, this is the place where I will get the final remainder. So when I divide 5324 by 29, 17 will be my final remainder. But if you want the answer by taking some decimal points, put a point here. Now you can continue as it is. Understand? So how many times it goes? 3. 3 5s are 15. 2 will be my remainder. Anyhow, after putting a decimal point, I can add a 0 here. So 5 into 1, 5. So 20 plus 5 is how much? 25. Yes or no? 20 plus 5 will be 25. 25. Now 25, how many times it goes in 8? 3. 3 8s are 24. Remainder 1. Anyhow, so 183.58. This is my answer. Simply you can write directly 183.58. Or if you want to write in quotient remainder form, quotient will be 183 and remainder will be 17. We'll take one more example. Let us take some 75432 divided by say some 30, no, let us say some 88. 88. I want to divide this number by 88. So write 88 as it is. 75432. Anyhow, last number is for the remainder 88. What is the nearest tens figure? 90. Leave this 0. So to get 90, how much I need to add? Plus 2. So plus 2 will be my complement. Understand? So now I am going to divide the number by 9, but indirectly I am dividing with 88. So just take the first digit 7. 7, will it go in 9? No. So take 75 at a time. So 75, how many times it goes in 9? 8 times. 9 is 72, remainder 3. Now what I said, after dropping every quotient digit, multiply with the complement and add to the next number. 8 into 2, 16. So 34 plus 16 is how much? 50. How many times it goes in 9? 9 4s are 9 5s, yeah, 9 5s 45. Remainder 5. Now 5 into 2 again. 5 2s are 10. Add it to next number. 53 plus 10, 63. So 9 7s, 63. Remainder 0. 7 into 2, 14. Okay, 2 plus 14, 16. So 16 will be my final remainder. See, this place, especially this place for the remainder, but I want the answer in decimal points. So put a point, how many times you continue like that, okay? So 9 into 1, 9, remainder is 7, put a 0, anyhow decimal point came. So 1 into 2, 2, so 72. Anytime, how many times? 8 times. So what is my answer directly? 857. This is my answer. What is the answer? 857.18. See, you may observe one thing. Here I have taken the numbers 29 or 88. This can be applicable to any number, but with a little change. Suppose if I am taking some 21 here or 83 there, okay, then what is the nearest to base? It will change, right? Nearest to tens. So let us take two more examples like that. Understand? Now let us take some examples like this. Let us say 53423 divided by say some 41. I want to divide this number by 41. So write 41 here, but okay, 53423, last number is for remainder 41. 41 is near which is its nearest to tens? 40. If you go for 50, you will get 9 as a complement, which is a bigger number. Every time it will give some bigger values and it will be some cumbersome to calculate. So what you need to do here, you just go for the base 40, leave the 0, and to get 40 what I need to do? Minus 1. So we are here, yes, you should be cautious. We are going to take we are getting the negative complement here. Yes or no? So we should be very cautious when we are dealing with the negative complement. Right, now start. First take 5. Okay, 5. How many times it goes? 1 time. What is the remainder? 1. Put it before the next number. Now 1 into minus 1. Minus 1. 13 minus 1 is how much? 12. Now 12, how many times it goes? 3 times. 4 is 12. What is the remainder? 0. Now 3 into minus 1. Minus 3. Yes or no? 3 into minus 1, minus 3. 4 minus 3 is how much? 1. So 4, how many times it goes in 1? No. So 0 times. 4 0 0, remainder 1. 0 into minus 1, 0. So 12 minus 0, 12. So again how many times? 4 3 is 12. Remainder 0. 3 into minus 1, minus 3. So 3 minus 3, how much? 0. If I am getting the remainder 0, that means what is the meaning? I am going to get the exact answer here. You can simply check once. Suppose if I check in the mind by multiplying the table, 41 ones are 41. What is the remainder? 12, 124. 41 3s are 123. 1 remainder 12. It doesn't go. So again 41 3s are, yes. So my answer is 1303. Exactly. Whenever I am getting 0 remainder here means it doesn't mean that my quotient figure, that is 1303, and it is exactly divisible here. So there is no remainder. Let us take one more example. 74362 divided by say some 73. I want to divide this number by 73. Check here. 74362 73. The nearest tens is 70 and the complement is minus 3. Why? Because I am subtracting 3 from 73 to get round figure or 10 nearest to tens. Now leave the rightmost digit for the remainder. Now take first digit 7. How many times it goes? 1 time. What is the remainder? 0. 1 into minus 3, minus 3. 4 minus 3, 1. Okay, so how many times it goes? 0 times. 1 remainder. 0 into minus 3, minus, okay, sorry, 0. 13 minus 0, 13. How many times it goes? 7 ones are 7. Remainder 6. 1 into minus 3, minus 3. 66 minus 3, how much? 63. How many times it goes? 7 nines are 63. Remainder 0. 9 into minus 3, minus 27. Now you got the turn here. 2 minus 27. Is it possible? No, it is not possible. Yes or no? At that point of time, what you need to do, okay, here the before quotient figure should be reduced by 1. That means we should not, 63 means we should not go for 7 nines or 63. Why? Because in the next digit the subtraction is not possible. So we have to go for here 1 digit, reduce it. So 7 8s are 56. If I take 63, 7 8s are 56 means what is my remainder? My remainder will be here 7. Now 8 into minus 3, minus 24. everything will change. So 72 minus 24, how much? 5 by 4, 2 plus 6, 8. So 48 will be my final remainder. Remember, the problem with the negative complement is whenever you are subtracting something, sometimes subtraction is not possible. Then you have to go one step back, reduce the quotient figure by 1, then again go for the process. Now 48, put a decimal point. How many times it goes? 7 6 are 42, remainder 6, or you can add a 0 after putting a decimal point. So 6 into minus 3, minus 18. So 16 minus 18 is how much? 5 by 4, 2, 42. So 7, how many times it goes? 6 times, remainder 0. Anyhow, one more 0. 6 into minus 3, possible? No, not possible. 0 minus 18 is possible. So that's why I'm making one less, that is 7 5s are 35. 7 5s are 35 means what is the remainder now? 7. So 5 into minus 3, minus 15. So 70 minus 15 is how much? 6. Okay, 55. Anyhow, I got my answer up to 2 decimals. So like that. You may think where it stops, where this process stops. You may think like that. You know where it stops? Whenever in this place, whenever the remainder places, okay, whenever we get the multiple of 73, the main divisor, whenever we get the multiple of 73 here, there it stops. Understand? Like that. Now, so what is my answer? 1018.65. Like this, you can divide even triple digit also. Let us see 2 more examples in triple digit. Suppose here what we did, we have seen the double digit and double digit, right? Now we will see the same Arthur Benjamin for the triple digit, but provided condition for doing the triple digit divisions, you need to know until 100 tables so that you can easily do the division by triple digit. Understand? Now let us see those problems. Right friends, now let us see an example of Arthur Benjamin division by triple digit. That means 53487. I want to divide it by 789. Now write 789 here. 53487. Anyhow, last number is for the remainder 789. What is the nearest to tens? 790. Yes sir. So 790. Leave the 0. What is the complement here? 1. Now, anyhow, start with the 5. 5 will it goes in 79? No. So take 53. Even 53 is also not going. Take 534. Only 534 will go in this one. Now, what will you do this time? You will check 79 table. How many times 534 goes in 79? So if you check like this, 79, if you go for 8 times, no, even 8 times also it will go beyond. So to take 7 times, 79 7 times. So 79 7 times you have to do in the mind. 79 7 times, 490 plus 63. 490 plus 63, how much? It is going even beyond 553. So I will go for 79 6 times this time. 79 6 times, 420 plus 54. 420 plus 54, 474. So 534 minus 474. What is the remainder? It's 60. 534 minus 470. See, I am doing the calculations in the mind. You also do in the same way. 534 minus how much? 474. 534 minus 474. That means 4 minus anyway 0. 53 minus 47. 53 minus 47 is how much? 6. So it is 60. So 60 is my remainder. Now, okay. How many times it goes? Yeah, 6 times. Now 6 into 1, 6. Add it to next number. Sorry, not here. 60 here. So 6 into 1, 6. Add it to next number. 608 plus 6, how much? 614. Now check 614 how many times. Already we discussed 79 8 times. Let us say 79 8 times. 560 plus 72. 560 plus 72. 632. No, it is going beyond. So let us go 79 7 times. 490 plus 63. 490 plus 63, 553. So 614 minus 553. Yes, it will go. So 614 minus 553 we have to do in the mind. Let us do like this. 614 minus 553, right? So 600 minus, okay. 614 minus 500. Okay. Okay, 114 minus 53 you need to do. 114 minus 50, that is 11 minus 5, 6, and 4 minus 3, 1, 61. So 61 will be my remainder. You can do in the mind easily, doesn't matter. 614 minus 553. Okay, so how much you are getting? So 47 plus 14, yes, that's done. 617. Anyhow, how many times it is? 7 times. 7 into 1, 7. 617 plus 7 is how much? 624. Now when I am dividing the number, this will be my remainder and this will be my quotient figure, but I want to do in decimal points. Put a point, add a 0. 624, how many times it goes? Again 7 times. Yes or no? So 7 times, how many times? Okay, 562. Okay, fine. 7 times, how, what is it? 553. 553. So 553 means 153. So 124. Okay. 624 minus 553. 624 minus 3. 621. So 621 minus 50. 621 minus 50. How much will you get? 571. 571. 571 minus 571. So 71 will be my remainder. 7 into 1. 7. Add it to next number. So how much will you get? 770. Now this time how many times it goes? I think 9 times. Is it? Let us see. 9 7 is 63. 630 plus 63. Okay, sorry. 630 plus 81. 630 plus 81. That is 711. Yes, it goes. So 8 times you can go. 630 plus 81. No, it is 9 times. So what is my answer? 67.79. So like that, there is a, maybe the double digit after decimal point will be an approximate one, but even though we are getting this much answer, so what is our answer? 67.79. Even triple digit also we can do like this, just multiplying the tables until 100 in the mind. So friends, like this we can do the division in an easier way. So let us move to the next topic of our Vedic maths.